morning. Very happy to have you here. This is a big thrill for me to be here in Jakarta, and I so much appreciate you coming. This is a very special meeting, a beginning of this user community. It's a special time in the history of Indonesia. It's a time to look forward, and in this morning's presentation, we heard from Indonesia's leaders just how important they see your work. Your work is clearly about seeing, illuminating, creating a future for Indonesia, improving what we can do, seeing into the future. Well, my name is Jack, as most of you know. If you didn't know that, you're in the wrong room. And as I said before, it's a great honor to be here to celebrate so many things with you, particularly the launch of this user community. The purpose, as Ahmed talked about for this meeting, is to learn. The purpose of the conference is all about you and your work and helping you do your work better. It's about learning and sharing, learning from each other, seeing what other people do and copying it, learning how to collaborate, build new friendships. And you particularly are interesting because you come from every aspect of Indonesian life, from the private sector and the government sector, at the top and at the bottom. You are different disciplines, different kinds of organizations, but you are using common technology, a common vision. This is what makes this room so very special. So at the beginning of this meeting, I would like to have all of you stand up and introduce yourself to one new person. Tell them who you are and why you're here. Could you do that for me now, please?
Hello.
Thank you.
Hey, buddy. How are you? Good.
Turn around.
Hi.
Yeah.
How are you? Omar. Nice to meet you. I'm working in Esri as Director of AI and Machine Learning. Awesome. Okay. Awesome. Awesome. Perfect. We're going to show some prediction scenarios today. So we have been building some capabilities that can help you make predictions. So we're going to show this today. Are you using any kind of imagery? Satellite imagery? Awesome. Awesome. Perfect.
Good, thank you.
That as well. Very nice to meet you.
Perfect. Thank you very much. That's good. Excellent. Good. Thank you. This is good. Now, sit down. Thank you. Again, one of the purposes of this meeting is for you to create new relationships, because the power of geography, the power of GIS in Indonesian society will depend upon us being able to collaborate and work together. This fundamentally requires friendships and understanding and relationships, sharing, learning from each other. This is what life in a way is all about, is this remarkable thing that only humans can do. While the technology is important, and I'll spend a lot of time on this, the humanness of this meeting is something I want you to remember, especially you. Now, your work in this room, but also your colleagues around the world, are working on virtually all the major challenges that the world is facing today. things like climate change, things like housing, things like the environment, development, natural resource management, all of those things that we heard this morning from your leaders here in the room. And at the beginning of this conference, I'm going to show some of the examples of work going on. These examples show users' work this year in natural resource management, forestry, exploration in petroleum, the management of agriculture and fisheries, managing land information, parcels, the ownership of property, the foundation for social infrastructure and rule of law. This is happening in developed countries and sophisticated cities, but it's also happening in rural communities in developing countries, in places like Zambia and Ghana and across Asia. People are learning the geospatial technology ground up with new technologies that make GIS affordable and accessible for everyone. GIS is being used in creating the future, urban planning, urban design, planning regional strategies, and national planning. These examples are attractive. I'll call to your attention the Ministry of Spatial Planning improving spatial planning down here in the right-hand corner. Zoning. I had breakfast with the governor of Jakarta this morning. He has a vision to create the next generation of Jakarta using zoning as a framework, 3D zoning. And it's fundamental to geospatial. GIS is moving into buildings at the room level. We are using and exercising GIS to do not only urban planning, but building management, room and space planning, and being able to bring in BIM models, building information models from our colleagues in the engineering and CAD world. GIS is being used for transportation planning, not only road network planning, but transit, public transportation access, busing. It's now used for managing most of the larger airports, including Jakarta here in the world, and ports. I'll call your attention to the one in the lower left. This is in Germany, where they're using AI and machine learning to be able to forecast road maintenance activities. And look at this interesting map in the lower right by Scania that is looking at transportation modeling with dashboards. In the engineering field and public works, we see remarkable work going on at the engineering scale. And look at the lower right here, the roads and highway management program that is going on right here by the Ministry of Public Works, looking at all the projects in real time. Your work in utilities is not only doing asset management, but it's allowing us to look underground with augmented reality. We can see dashboards of things like water leakage here, right here in Indonesia on the water networks, and electrical transmission and electrical utility work of all kinds. Looking to the future, GIS is paving the way for 5G, understanding the impact of 5G on the technical footprint within our societies. In the private sector, it's amazing. The private sector is waking up to the power of digital geography, being able to pick the right location, being able to automate routing of trucks and vehicles, being able to do retail assessment to pick the right site, looking at insurance and bank monitoring of various types. Statistical agencies are increasingly connecting with geospatial information. And here again we see census, maps, the reporting of census maps not only within the nation but beyond for supporting things like SDGs. And here again we see the monitoring and spread of infectious diseases occurring in the city of Jakarta, making people aware of the patterns and the processes of disease. As we heard earlier this morning, natural disasters are not just unique to Indonesia, but they're certainly a major phenomena that's driving social policy here, whether it's fires or earthquakes or tsunamis. GIS is being used to be able to see what's possible and respond. Look at this amazing simulation in the lower left of looking at the Pala and Donggala earthquake and the impact of that on flooding. Just amazing work. I'm just so impressed by this. And these are, you should feel proud. You should feel proud of this work. It's amazing what's going on here. And map making. There's a revolution going on in digital map making. We're not just using the computer to make simple maps, we're automating the process of making maps at many scales. And this has huge impact. These examples here, for example, with Swiss Topo, show very small scale maps being able to be generalized to very large scale maps and back and forth. Map production is becoming automated. At the Ordnance Survey last year, they increased their productivity by 1,200%. They shortened the time from 14 months down to 2 weeks for regeneration and processing of their entire base map for the entire UK. Just amazing work. This is amazing work. Here in Indonesia, we already saw in the previous presentations that not only are you making great projects, but you're increasingly opening up access to your data for others to use. This is agency to agency through open data portals and open services portals. The OneMap portal that was profiled earlier is showing how one agency can be in service to other agencies, but also in service to the private sector, to different levels of government. So the architectural patterns here in Indonesia are already alive and well. I've shared this series of examples for you to get your mind thinking, and it's appropriate that we acknowledge great work, but we also look ahead. What is the future going to be like? This is only 2019. And look at the progress that's been made in the last 5 years. What vision will guide us into the future to make Indonesia smarter? So I would like to share with you a kind of metaphor for looking at the future. The metaphor is a nervous system. That is, GIS, your work, is about creating a more intelligent infrastructure, a nervous system for managing the country and your respective organizations. So let's start with this. A nervous system, and you all have one, so you know very clearly what it's like. We all have nervous systems. A nervous system is essential for us as human beings. Our central nervous system, our brain, is our most important organ. And this nervous system does more than simply stimulus response. It also brings information together and creates a kind of intelligence. It integrates data from many sources. Sound familiar? It processes that data and it couples it with our logic, sometimes our emotion, and then ethics and values. This is why it's important for us to be together, to have commonly shared values. And then it responds, and our nervous system responds in a coordinated way. It isn't one arm going, it's coordinated action. This is fundamental to the way humans live. They carry out not only coordinated action, this is something that the governor this morning said at breakfast. He said, I want my different departments to do coordinated action, not just one department not knowing what the other department is doing. And then we, or most of us, learn. We learn. We'll hear more about that in a few minutes. Learning. And with the advent of new technologies, we certainly see how GIS as a learning system can be empowered by machine learning and AI. Now, our world, our natural world, and also our cultural world resembles our body. It's a complex and interconnected ecosystem of things, of processes, and it's self-healing, like we have in our body. We make a mistake and it heals. And it's always changing. And by the way, for as long as we know, humans have been part of that ecosystem. Now, the human footprint in that ecosystem today, with population growth and the impact on climate, is creating many challenges for us. And there is almost no country at greater challenge than Indonesia. Some would say overpopulation. And in the epicenter of climate change, with its thousands of islands, exposure to the shoreline, tsunamis, hurricanes, you are feeling it. And we're seeing it unsustainable. This pattern of human activities, let's face it, ladies and gentlemen, it's not sustainable. I wish it was sustainable, kind of a good life, but the footprint that we are making on the natural world, some would say we're overextended. We're spending more of nature's capital than we can afford. Most biologists suggest about 1.7 overstepping the ability for the natural systems to sustain it. So what can we do? Well, little things like I plant trees, recycle, all those things that people are talking about today. But you in this audience are very special. Why? Because today, in many ways, our world needs a kind of a new nervous system, one which is intelligent and speaks to, as we heard this morning, at the policy level, everyone. A system that creates understanding and enables collaboration and action, more intelligent action. Now, such a nervous system, and I know I'm a little biased about this, but not too much, this nervous system, I believe, geography is essential. Geography is the science of our world. If you look it up in the dictionary, this is what it is. It provides content, brings together all of the ologies, sociology, geology, biology. It brings these ologies together. It provides both content and context. And it also is a common referencing system that all of us relate to. This is why particularly I'm excited at the leadership's presentation this morning, because from the president on down, people get it here. It helps us see. It helps us understand complexity and relationships and patterns. It allows us to bring together everything to see the whole. This is the power of location. This phrase, the science of where, provides a kind of framework and process. The science of where is geography and digital GIS together. And it starts with measurement. Whether it's geodetic measurement or thematic measurement, that's the foundation. And then it steps into visualizing and analyzing and modeling. And if we look at these blue words, it's about sensing and understanding. That's what your work is about. And then supporting planning and design and decision making. So many of you do all of these steps, and some of you just do some. Some of you just do planning. Some of you just do design. Some of you do just measurement. But the community of you here in this room, why I believe you're so special is that the community of you represents the foundation for a geospatial nervous system for Indonesia. This is the big idea. And playing around with this in various forms always comes up with the same process and framework. This is why it's so important. Public and private, national government, local government, NGOs, participation, citizens. It's a foundation for the future. And your work, whether it's a project, GIS, or whether it's a system of record where you're keeping all the records together, are evolving into another pattern. This pattern is a system of systems. It's interconnecting the individual cells of activity, the individual disciplines of activity, the individual agencies. In other words, your work is already contributing to, it's building this infrastructure foundation. It's intelligent. It's responsive. It's integrating all the data sources, just like our brain integrates data sources. It creates a kind of digital system that is connecting everything. Isn't that a beautiful thing? This is just a beautiful thing. Your work is really a beautiful thing. It's applying this science, the science of spatial or the science of where, in so many ways. Now, your individual work, your systems or your projects, with the advent of the internet and services architecture, your individual work is also integrating into a global, a national and global system. This is not happening just by design. It's happening, it's just happening. And everywhere I travel, I'm seeing it emerge. People are sharing their data. They're using each other's services. They're mashing it up. They're bringing it together. They're creating integrated geographic knowledge. Again, I'll reference this conversation with the governor this morning. He said, I asked him, what are his big problems? He said, my number one problem is integration. Right away I thought, I've got the answer for you. Geography. The mother of all sciences, to bring it all together. So very gradually, I am seeing as I travel around the world, incremental advances in sharing and collaboration. A new kind of era. People have described the technology aspect of this as being a foundation for enabling 4.0 initiatives. It is certainly that. But it's also creating a system of understanding things. Oh, I understand. Oh, I understand. And understanding precedes action. So, ladies and gentlemen, you, particularly you in this room, are the people that are building this infrastructure that will create the next generation of Indonesia. Now, this geospatial infrastructure is interesting. At the technical level, it supports individuals. I can access the data. It also supports various kinds of organizations, teams, cities. It also is increasingly connecting the community, citizens, constituents. And it's all about sharing and collaboration. Those of you who have GIS in your backgrounds, this geospatial infrastructure is GIS at scale. And it's accessible not only to the GIS professionals, but also everybody else. It's distributed and interconnected. So listen carefully. This is not one big system. It's not one big central system. No. It lives in a distributed environment on the web with open access to services that can be mashed up and connected for different kinds of applications. For an individual, it provides many distributed capabilities that I can bring in, like AI and machine learning, or databases from a different place. I can read in tracking servers or real-time information or the IoT. It's like a treasure of accessibility, of access to different kinds of services and content. Again, enabling this vision of 4.0 Indonesia. It delivers powerful applications on top of the infrastructure. Yeah, I mean, the infrastructure is emerging, and I showed you the evidence that's happening right here with portals that are being implemented. Often these portals are, oh, I'm just making my own little portal here and sharing it. But I'm telling you, where that goes is integration of portals of portals. And that infrastructure delivers powerful capabilities for GIS projects. I can be a GIS professional using Pro and connecting to distributed services and bring them together. That's one kind of user. But also, it provides general purpose mapping, what's going on for everybody in organizations. It shows visualization. It can support now field workers who have, let's see, devices. Oh, somebody took my cell phone. You've got my cell phone. But it can access through devices, something that almost every Indonesian now has. So I can do field work, I can do field collection, I can do crowdsourcing, I can connect to the network. Technically, all of this is now possible and working. It can integrate data science, and it can provide the dashboards. Again, the governor this morning said, I want a room where I can walk into and see everything going on in my city. Interesting. This can be done. Technologically, it can be done. But what's missing, well, I'll get to that in a moment. The technology now allows us to not only develop the infrastructure for the haves, but also the have-nots, providing engagement like web maps that can engage citizens or special interest groups. We can connect the government with private sector so that there's more intelligent development occurring. We'll hear more about that in a few minutes. Businesses can be empowered to make more intelligent cities. And it just goes on and on. But do you guys get this idea? Do you understand it? Just tell me, because I could shut up and, I mean, you need to understand this concept that your individual work can be interconnected now with the web and geography to create the infrastructure. There's no magic. It's just a matter of interconnecting it. And out of this, Ahmed already shared the bottom line, which is we can begin to interconnect your individual work into systems of systems and create more responsive, real-time infrastructure for the nation, connecting IoT, making individual departments smarter and sharing and more integrated in their vision. I'm going slowly because this is a big idea that involves all of you and will involve all of you. This is a little diagram that I put together to kind of show this kind of concept. We can take different agencies who might have their own little portal sharing data outward and interconnect those into a portal of portals so that we can search the portal of portals and support citizens or support agency to agency collaboration. And this is not a concept that does not live. It lives in Abu Dhabi. They have 132 different departments. They're all sharing, serving, using content of this type already. This is happening in the UK with the Ordnance Survey, similar to BIG for the UK. It has a more narrow scope, but they're linking real-time observational data to their mapping system and then serving it out to the provincial and local governments. It's happening in local governments, small local governments across the world. It's happening in utilities where they're measuring real-time IoT grid and serving it agency to agency. And it's changing the fabric. It's creating more responsive organizations. It's integrating citizen science. It's providing standardized reporting. It's organizing community involvement. And as we've already heard, it's organizing sustainability at the UN level. These are a few examples right here in Indonesia. Using services, we now see Batam reading in AIS data for ship monitoring off the coast. This is showing, you can see this beautiful line, the marine boundary of where the ships stay so they're not taxed. We can see it. We can see how flooding is occurring in Jakarta and how situation is, awareness is being showed by Tangerang. Local governments, beautiful, beautiful. Systems of systems. So I've been describing a kind of revolution here. And my sense is this is just barely beginning. We're now seeing the evidence of what this is going to be like. This geospatial nervous system that emerges will transform Indonesia, your organizations. It'll make things more efficient and wise. Now, the question is this just technology? No. Your work is essential to make that happen. Building an intelligent nervous system takes more than just technology. It's not like buying Microsoft's Word or developing an open source solution or no. It requires leadership. That's why, again, the leaders here for this country is so important. The leadership from the president on down is profound. It requires envisioning what's possible and then learning and sharing. This is why this community is so important. It requires some strategic thinking big. What can we, well, thinking big and big. It's a two-word meaning. It involves engaging everyone, not just our own little stovepipe. And just like the kind of work that you've been doing, it requires passion, a real genuine interest in doing something, and then leveraging this vision. I'm now going to shift gears and talk about what Ahmad suggested I was going to talk about, which is our work. I've talked about your work. It gives us the evidence of what's coming. I've talked about a vision, and now I'm going to talk about Esri's technology, and I'll go through this relatively quickly. Our work is about creating useful technology that helps you doing your work better. And we focus on ArcGIS. That's our main technology. It's our only technology, really. And ArcGIS has three parts. It's actually one integrated system, but it has three parts. First, it's a system of record keeping, just like a financial system, transactional updating. Second, it's a system of analysis or insights. Here I do spatial analytics, machine learning, whatever you want to call it. And third, it's a system for engagement. This is engaging across agencies, sharing maps, sharing apps, connecting people. It actually is a system of systems. ArcGIS is advancing rapidly, and we respond to many requests by you. This is how we build the technology. But also we're responsive to changes of measurement technology. Things like IoT or new kinds of sensors. Our partners like Planet Labs or Digital Globe or new photogrammetric measurement tools. These are all new generations of technologies that we have to be integrating into our platform. Second, ArcGIS is responsive to changes in the technology. We're now focused on not only faster machines and what that means, but also cloud-based machines and also microservices. So I just want to assure you that we're staying current with the exponential changes that are occurring in the whole IT world. And finally, it's about science. Not only staying current with science, open data science, open science, but also inventing new tools that affect science in positive ways. Now, this ArcGIS has a key element in it, which is Portal. Portal is not the traditional Portal. Portal is a major piece of the system. It organizes and manages all aspects of geospatial knowledge. The data, of course, the maps, the data services, the models, the notebooks. It also organizes identity. So I'm Jack. I have access to certain data, but not others. It also organizes groups. So this department can share data with that department, but not that department. So identities and groups, these are key elements. And it puts these together in a kind of integrated experience, both within an agency, but between agencies, and between an agency and the public itself. Now this portal technology does a very important thing. And most people don't understand this, so I'm going to take a moment, if you don't mind, and explain it. These are all the different generic types of spatial data. BIM data, building information data, LiDAR data, real-time data, tabular data, unstructured data. So when we heard about the idea of one data, not just one map, what I want to say is that you can bring in all types of data and integrate it using Geo as an integration platform. How is this done? How is this done? You leave the data where it's at, on this computer or that computer, but you abstract the data on the computer as a web service. And you reference the web service in a portal. So I can have this agency doing BIM data, I can have that agency doing LiDAR data, this agency is about imagery, and so on. But I can dynamically bring that data together in a new language. What is this new language? It's an abstraction. It's maps. It's 3D maps called 3D scenes. And it's feature layers. This is the technical way that we describe it. But the key concept I want you to know is we can take data and leave it right where it is and abstract it and put it into a portal that people can search and find the data. But unlike metadata catalogs, this data is ready to use immediately. It's not, okay, then I can download the data and use it. No. I can immediately find the data, push a button, bang, I can use it. That's different than the concepts of the last 20 years of metadata catalogs and searching. And this was referenced by several of the leaders this morning. We need to have data that's responsive and ready to use. Real-time data, like the real-time hurricanes, I want to mash it up with my trucks and see where I have a problem. I don't want to do it in a data integration step, no. Okay, everybody understand this concept? So ArcGIS is now services-based. It used to be client-server-based, now it's services-based. So everything's a service. To bring this integration together, I need to serve my data, make it available openly, so that others can use it and mash up their services with my services. That's the magic of REST and web services. Now, this platform is a new generation of ArcGIS. It's a new generation of ArcGIS. And it has been designed to be an open platform. It's not only built on open standards, OGCs and others, it integrates open science into it. It also open sources major pieces of the platform in GitHub and others. And it also has open APIs so that developers can craft solutions that are creative. This is ArcGIS in the 21st century. Now, we have been working just about every year on making improvements to ArcGIS. Esri spends about 1/3 of its revenue on R&D, and we spend it in a portfolio of different activities. This amounts to about $1/3 billion a year. So we keep pushing the envelope every year on new content that's available as part of the system, new mapping tools, new analytic tools, and so on. So I'm going to spend the rest of the time going very quickly through this portfolio because some of it will be very interesting to some of you, and others, okay, see it in the workshop. As I say, we got a lot of training sessions here about it. Let's start with content. About 10 years ago, we began to develop a cloud system called ArcGIS Online, and we assembled the best available content. We call it the Living Atlas. And it has now 7,000 layers of content for the world. We buy all the commercial imagery. We integrate OpenStreetMap. We have HERE data, our strategic partners in streets, that is available to all of our users and the outside world for free. This is a massive exercise for us. Today, we have over 8 million users of this cloud-based services environment. It's basically portal in the cloud for all of our users. There are also 25 million data sets that have been shared by our users. So users are sharing their data and using each other's data. It's kind of a big portal in the sky. It connects to local portals, and some data from local portals are available through this. And we keep adding to this content every year. These are some of the new updates for geospatial information that are available right here in Indonesia. Imagery for the world, change analysis for the world, land cover for the world. This is exciting. And we keep adding to it, making it more up to date, linking our agencies, partners, our users to this database so that they are getting advantages from this services platform. I'll come back to this later. Is this interesting to you? Okay, good. Another big innovation area is smart mapping. Smart mapping uses machine learning to help our users automatically create beautiful maps, so they don't have to be a cartographer to build beautiful statistical maps. Lots of innovation happening here. Story maps are an innovation about telling a story around a map with text and pictures. There are now over 1 million stories that have been published in the last 2 years, and there are many, many, many millions of users that look at these story maps as an educational platform every day. In my country, the executive leadership of the country looks at story maps to get their daily briefings. So it's a new medium for users. Some of you work with story maps, but this summer we released a new generation of story maps that promises to take this, instead of 1 million story map stories, it'll go to tens of millions a year of new stories, a kind of new email. I like to call it geography mail. Telling stories to the governor, telling stories to the president, abstracting web services with text and photographs to tell the stories of your work. In the traditional mapping and cartography, we've added new tools. Each year we try to improve map production for topographic and charting and aeronautical charting. But this year we added particularly some new tools for generalization and offshore cartography contouring. We've also integrated with Adobe Cloud tools for the design and specialized cartographic community. So you can be in Adobe and access the services coming out of our content servers. For the field workers, there's a whole bunch of user applications. What are these applications? They're the dashboard to look at where my people in the field are. There's collector tools like Survey 123 for tabular collection, or Collector for collecting features in the field, whether it's incidents of crime or incidents of street lights or a broken fixture. That's a kind of app that runs on a standard device. This year we introduced a new tool that's available to all of you called Quick Capture. Quick Capture allows me to drive along in a car and with, as you can see on the screen here, just make an observation. You don't need to know very much. You just say, I see a broken tree, I see a broken device, I see a crime going on, I see, and it captures the location of it and puts it right into the database of your enterprise system. So these field observations can be collectively put into an integrated enterprise system, and then people can look at their workforce. What are they doing out on the field? They can track also their workforce. This is a new capability. There's a workshop on this at this conference, being able to track everybody working inside of an organization. This has been a challenge for putting it into the enterprise environment, for improving productivity across the organization. There's improvements in editing and data management, better editing tools, especially in 3D. There's stronger industry models like utility models and parcel fabric models. And also we've worked hard to integrate the powerful engineering tools of Autodesk Corporation for BIM modeling into the GIS. But for some of you, the lower right is important. We keep working on not only traditional database environments like Microsoft's databases or MySQL or Postgres, but also new generations of data management tools in the cloud. Is this level of detail relevant to you? Should I keep going? I could go faster, or I could go slower. I want some crowdsourcing here to help me. You're not giving me any feedback. Slower? Faster? Slower? Okay, never mind. I'll try to just do my best. We are making lots of improvements in 3D visualization. The improvements here are seeing BIM models as scenes, new tools for symbology, like special effects, like shimmering of water, city modeling, improving not only above ground rendering, but also below ground. This is a big one. And also integrating with augmented reality and virtual reality, tools that allow us to see what others can't. 3D is not limited to visualization, it's also analytics. So I want to be able to do analytics in 3D, like view sheds or interactive profile analysis. Volumetrics is a new frontier for Esri, looking into the ocean, looking into the oil geology profile using voxel technology. And these capabilities are not just one app, they're in all of the apps. The free ArcGIS Earth Viewer, kind of like Google Earth, the City Engine tools, the ArcGIS Pro tools, and also Scene Viewer, a web access to 3D. So 3D isn't just one tool, it's everywhere. 3D is everywhere. Today's standard of GIS is 3D. It's actually multi-dimensional. In the field of spatial analytics, we keep adding to the hundreds of tools things like better charting, or spatial temporal modeling, or new raster functions. But the one that I'm most fond of are improved processing. And let me go through these carefully. On the upper right, we can see a new tool that allows you to take your tools as you interact with data with tools and automatically build a model. Kind of memorizes your interactive work. It builds a model that you can share with somebody else. So it records your work. We can also take models and automatically convert it into Python scripts for doing advanced analytics. We can take big data, like billions of features, and process them using a technology known as the geospatial server with Enterprise. But now, this summer, we released a new capability in your Pro workstation to be able to deal with millions of data sets using multi-processing tools on your laptop. When you get 2.4 of Pro, many of you already have it, you should notice that things can be speeded up. This is not an extension, it doesn't cost anything, you just get it as part of your maintenance. Hosted Python notebooks are a new server capability introduced earlier this year. How many of you are Python users here or know Python? Okay, I'm really embarrassed. Should raise more hands. Well, Python is a programming language for users to be able to script functions. And we have now implemented Python server notebooks so that you can build or script processing and share it with other people. This is very useful for automation, but look at the diagram. With a Python notebook, I can integrate in geoprocessing function or mapping with big data, data lakes, with open science libraries like AI and machine learning libraries. I can bring these together and create scripts that we can share. Is this clear? So in this generation of technology, this Python notebook is going to make progress for you to share and integrate your work. Big step here. Using Python notebooks, but also engineered directly into our product, we're able to leverage artificial intelligence or AI tools and machine learning and deep learning. So our work here is not to become AI experts. It is to integrate AI and machine learning libraries with our standard tools so that our users can leverage the power that's emerging in this very rapid growing field. So the talk of technology today is deep learning and AI and machine learning. Everybody's talking about it. We can't invent all the tools here. We can invent a few highly specialized spatial machine learning tools. But as this diagram shows, we're reaching over to the open source environments and allowing our users to leverage the power of all of that work that's going on. So I'm going to take a break for a moment and ask my colleague Omar to come up here and give you a little bit of vision. Thank you, Omar.
Hey, Jack. Thank you.
You're welcome. Here's it.
Thank you so much.
You're welcome.
Assalamu alaikum wa rahmatullahi wa barakatuh. How are you guys doing today? Energized? So, AI, machine learning, deep learning, it's a buzzword right now. You can find it on your Facebook live stream, your Instagram feed, everywhere. Everyone is speaking about it, right? So, I want to share with you quickly what is the difference between these, what are we doing in Esri to bring these amazing technologies, and show you some real-life examples that are directly related to one map and the amazing initiatives that our directors have talking about today. Artificial intelligence is the idea of achieving human-level intelligence, and it's not a new idea. The term was first coined in 1956, so it's an old idea. It's just becoming very powerful recently due to three main things. First is the massive explosion of data. We have data from social media, sensors, IoT, telecom, you name it. Machine learning is one field of artificial intelligence that's about learning from data to derive rules and extract patterns instead of being explicitly programmed. And deep learning is one type of machine learning using a specific technique called deep neural networks that is becoming very good processing high-dimensional data like images, voice, and text. And we're going to see some examples for that. Now, you might be asking yourself, what does this have to do with ArcGIS? The intersection of AI and GIS, we can see it in three main patterns. The first pattern is about finding objects and features from any kind of imagery or videos. So think of anything that you can detect as a human under 1 or 2 seconds. The rule is we can generally automate this through AI. So you want to find buildings, road segments, you want to have one map, you want to have like a small scale kind of map production at scale, detecting buildings, road segments, land cover. This could be achieved through AI, and these are examples for work we've been doing. The second pattern is about prediction, predicting geospatial events, events that happen in a location that are affected by spatial parameters, predicting road crashes, accidents, diseases, crimes, you name it. And finally, pattern detection, finding patterns in spatiotemporal data, finding emerging and fading hotspots in 911 calls, or 112 calls in our case, or finding statistically significant clusters in crash data, and the list goes on. And we do have machine learning tools in ArcGIS today, tools that we have been building for years. Like this, again, this is not new. We have a lot of new capabilities we're going to talk about, but we have been having these tools for years. Tools that can help you make prediction, find patterns using clustering techniques, and classifying land cover. And these are examples for some of these tools. So I really want you to have a look at these lists and see if you're using any of them today. Because if you're not, I definitely encourage you to do. These are amazing tools that can help you make prediction. For example, the forest-based classification and regression. We're going to showcase this today to see how we can predict diseases. You can find clusters and patterns, and you can do classification for land. Amazing tools, no need for coding, all at your disposal at ArcGIS Pro and Enterprise. Okay. There you go. And as Jack mentioned, we don't want to reinvent the wheel, right? There is a lot of progress happening on AI and machine learning everywhere. We have open source frameworks like TensorFlow, Scikit-learn, PyTorch, Keras, FastAI. And you have commercial frameworks like Azure Machine Learning, IBM Watson, Amazon SageMaker. We do integrate with all of these. And the main way of integration is the Python API. Any of you guys have used the ArcGIS API for Python before? Okay, I really invite you to do. Think of this as the glue between the amazing world of ArcGIS and the open data science world. And if you're using R, we do provide integration through the R bridge as well. So with that said, I want to start showing you some real examples. And the first example I want to talk about is disaster response. How can we use AI to overcome this problem? So hopefully my demo would show on the screen. Oh, I need to connect it here. Yep. So I want to talk with you about Hurricane Michael that happened on Wednesday, 10th October 2018. That was a devastating event, leading to a total loss of $25 billion in the US. and unfortunately 72 fatalities. Now, in events like Hurricane Michael or earthquakes or storms, and we have a lot of these unfortunately in Indonesia, we need to act fast. And by acting fast, I mean we need to have a quick understanding. Where are those damaged areas? Where are the areas that need high priority rescue? How can we act on this intelligence and send people to the field, collect data, and act on the intelligence? So I want to show you this end-to-end workflow. What we're seeing here is imagery collected after Hurricane Michael. And as you can see, unfortunately, we have a lot of damaged houses here. So what we want to do is we want to train a deep learning model to find damaged structures and find damaged roads real quick, and then taking this to ArcGIS to start seeing how we can act on it. So the first thing, to train a deep learning model to find damaged structures, you need to provide it some examples. Examples like this. So think of deep learning as a baby or a child that you show it different examples and it's gonna learn this. So these are examples for damaged structures. So the more you give it examples, the better. So we want an easy way to find damaged structures by giving a lot of labels. So we're gonna label some data here. So we're drawing polygons and we're defining each building, whether it's damaged or not. But this is gonna take some time. So why don't we crowdsource this? Why don't we have a lot of people label data for us? That's what we have done here. We have built an app using Web App Builder in literally 2 minutes, where you can go, click on a building footprint, like that one, and mark it as damaged or non-damaged. We have literally done this, like 10 people in Esri collaborating on that, producing thousands and thousands of examples. Next, we want to see how we can get this data to be in the form of chips, as we have seen. So if you go to Pro and search for a tool called Export Training Data for Deep Learning, this tool is gonna help you do this. It's gonna take 2 inputs. The first input is gonna be the imagery. The second input is gonna be the feature layer of the labels that you have just created. Once you run this tool, you're gonna end up with something like this, a folder full of thousands or hundreds of labels. Now we're gonna take these labels and train a model. Now, Jack has just talked about notebooks and ArcGIS notebooks, an amazing capability that enables you to access the world of data science and ArcGIS at the same place. So we're going to use ArcGIS notebooks to train a model to find the building footprints at the beginning. And the way we're gonna do this is through a capability called ArcGIS.learn. ArcGIS.learn is a new capability in the Python API that will help you train deep learning models so easily. You can literally train a model in 3 to 5 lines of code because it has abstracted the complexities of deep learning frameworks and enabling you to do this easily. So we're gonna access our chips and train our model in this line. And as you can see, the model is finding the building footprints. We're gonna train a second model to detect the damage on these building footprints. And as you can see, I'm using an ArcGIS notebook again. And this notebook, you can do a lot of analysis, and you can add whatever data from the Living Atlas or your organization easily, as you can see from the buttons here. And these are the chips that we have just extracted. So after you train that model, we want to consume it back from Pro. And I want to make a stop here. A lot of organizations these days are hiring data scientists and AI experts. But on the other side, the people who are going to use these models are not necessarily having deep learning knowledge. So we need to empower them. So once you have a trained model, you can consume it from ArcGIS using a new tool called Detect Objects. So Detect Objects using deep learning is going to take, again, 2 inputs. The first input is the imagery, and the second model is an EMD file, an Esri model definition file. Think of it as a wrapper around the model that you have just trained. And once you run that tool, this is going to be the results. So we have ran the tool, we have run the model against this area, and it's actually finding the damaged and non-damaged buildings, right, as you can see here. But then the idea of using deep learning is really automation. We want to have this at scale. So using the power of GPUs, we can actually find results in larger areas. So as you can see, we have run this across the whole county, and we can quickly find a lot of damaged and non-damaged buildings. Just to give you a simple example, we were working with a customer in Kuwait called Passy. They have spent 1 year having 5 people manually labeling building footprints, and 5 people working on daily basis for like 5 or 6 hours. We have developed a model that is detecting building footprints. It has detected 37,000 buildings in only 3 minutes. Can you imagine the huge value this is bringing to the table? Now, understanding where our damaged structure is one important thing, but understanding where our damaged roads is equally important. So we have done the same thing, collected labeled data, trained the model to detect where are those blocked areas in the road, and it's helping us finding which roads are passable, which roads are not. But then bringing this back to the GIS and acting on it is equally important. So this map actually shows the passable and impassable roads. And we want to understand how to optimize resource allocation quickly through the routing services. So these are a group of damaged structures. That's a fire station here. We want to send resources from the fire station to the damaged structures. We're going to use the routing services or network analyst to find the optimal route, and it's going to help us find the perfect sequence of stops. Now, how about taking it to the next level? How about having a situational awareness dashboard like this and using the workforce to start assigning tasks to people to go on the ground and collect data? So this is my friend Parker, and his title is the man with the plan. And he's collecting data on the ground that is directly integrated to Portal. And we can see here how many blocked roads, how many damaged roads, how many active workers in the field as a common situational awareness picture. Now, if we want to understand on a national level what is the level of damaged and maybe classify damaged, we can even bring more GIS layers and see another layer of intelligence. So by adding the parcels, we can start to understand the percentage of damage per parcel. Maybe we can classify damaged if we have more training data for damage, and do some filtering, like show me all the areas with like 60% of damage or something. So that's the true power of bringing AI with GIS, not just building a model or something, but really connecting the pieces together to answer a bigger question. So that was my first demo that I want to show. I want to tell you that it's not just about detecting damaged. We are using this capability today to automate a lot of tasks. And I wanted to think of AI as automation on steroids, not Skynet or Terminator, right? So what are the tasks that you want to automate? Maybe you want to find palm trees. We have a lot of palm trees here. So following the same methodology, we have built a model that is detecting and counting palm trees. So this can help you automate the task of understanding your production and how this is expanding. You can even understand the health of each palm tree by bringing the triangular green index and joining this with each detection to understand which tree needs inspection. We have done a project with one of our customers to do land cover, and I believe this is extremely important for one map, right? So deep learning is outperforming the traditional segmentation techniques in general when it comes to finding land cover. So this is showing actually how we have used ArcGIS to learn UNet to train a model to detect 12 different classes of land, and this is 94% accurate. And just to give you a quick idea about the value of this, so that was done with the Chesapeake Bay, and they spent 18 months labeling 100,000 miles square of land, and obviously by the time they have labeled that, it was outdated, right? Now, we have labeled on 1 meter resolution land cover across the whole US in 10 minutes using Microsoft's Brainwave with partnership with ArcGIS. Detecting roads, finding roads, detecting vehicles from CCTVs. This is actually live right now in Washington, DC, a system deployed in production, using feeds from CCTV and running deep learning models to understand how many cars, how many pedestrians, how many buses, etc. So you can see that obviously it's not there right now and it can't count the cars, and the possibilities are just endless. Now, I want to move to my next example about automating the process of finding issues and damages and road cracks in roads using cheap cameras mounted on vehicles. So that's a problem that's facing a lot of DOTs and municipalities, finding road cracks and sending resources to fix that. And what we have thought about, what about automating this using deep learning as well with ArcGIS? So we have got access to a public data set of road cracks, trained the model, and let's see how this model is working. Oops, okay. So the model, as you can see, is detecting those road cracks, and this is using a cheap camera. You can get a GoPro or any brand, $70 or less. and it's detecting those cracks in real time, and the images are geotagged already. Now, what happens when we bring this back to the GIS? Let's see. So, as Jack mentioned, having different notebooks, these are different notebooks that I have, and one of those notebooks actually is used to train a model for detecting road cracks. So this is the public data set for cracks, and we are training that model. And once we have these detections, we are bringing it back. Here, let's see. Okay. So apparently I have a lot of tabs open, so let's open another one here. The objective is to really understand where to send resources and how to prioritize actions. And as I mentioned, each detection is brought back as a point. So having a feature layer of all of those detections, as we can see here. So we can see which segments actually has the highest number of cracks, represented by the size of the circle, and this has a breakdown by the type of crack. And you can click on any one and observe the crack, right, and take actions. And think of anything that you want to automate from that perspective. Now, again, the theme here is automation, automation, automation. Anything that you want to automate, land cover, buildings, road segments, finding damage, detecting people, detecting road cracks, detecting road signs. Think of any use case, and the tools enable you to do this. I want to shift gears to another perspective, which is prediction, because that's another very important aspect of machine learning today. So what we're seeing here is Connecticut, and we want to use machine learning to predict asthma hospitalization on the block group level. So asthma is a disease that is caused by multiple factors, and having accurate predictions is going to help us understand how this disease spread and take action. We have this data, the number of people who have been to hospital due to asthma, on the census tract level, as you can see. But unfortunately, we don't have it on the block group level. So what we want to do is to build a machine learning model that can predict this accurately. If you want to predict anything, you need two things. You need input variables and output variable. The output variable is the thing you want to predict, which is the number of people going to hospital due to asthma. The input variable, think of anything that could relate to that. Maybe, let's see here what we have. So maybe it has a relationship between air quality, for example. So we have air quality data from sensors, and we interpolate this using empirical Bayesian kriging. Maybe it has a relationship with distance to air emitted toxic releases. Maybe distance to major roads, like a lot of traffic, causing pollution, causing people to have asthma. So we keep adding those variables here. Road density, spending on insurance, smoking, percentage of people smoking, median income, and the list goes on. Now, you don't really need to spend a lot of time to think about those variables, because there is a class of machine learning tools that can help you select the top variables automatically, and random forests is one of those algorithms. So if you go to geoprocessing and search for forest-based classification and regression, you can use this tool today to train a model. So you're going to add the variable that you want to predict, which is the number of people going to hospital due to asthma, throw in all of these variables that we have selected, whether they are like discrete variables or training rasters or distance features. You can optimize some parameters. And once you run the model, you're going to have two outputs. The first output is some statistics about the accuracy of your model. And this is very important. We don't want to use a model that's not accurate. One of the measurements to measure the model's accuracy is the R-square. And here we have a score of 86.8% for the R-square on the validation data, the data that the model hasn't seen before. And you can also see the top important variables. Maybe you can visualize it here. So you want to understand why asthma happens? This is why it happens. So apparently the top factor is the percentage of people smoking cigarettes, followed by the median household income, followed by spending on health insurance, and some other variables, like, for example, distance to air toxic releases. And finally, the model would predict on the block group level. So these are the results here. Accurate model predicting asthma hospitalization on the block group. Now, if you noticed, I have not written any single line of code in that example. So this is only one tool among a lot of tools that can help you make predictions. So we have seen examples for automating object detection and feature extraction, making predictions, and we have a lot of other tools that can help you maximize the value of your GIS. So I think the question is, how are you leveraging these tools today? Thank you.
Great. Amazing, isn't it? I mean, this is truly amazing.
Thank you.
I appreciate it.
Thank you.
Omar, thank you. One of the things that Omar did not emphasize is that all of what he did is available in ArcGIS Pro desktop now. So these amazing tools, look at the last release. This is not something new to buy. It's just something that you have to learn how to get smarter with your GIS. Now, imagery is one of the areas, one of the key areas that we see as important for machine learning and AI. And ArcGIS improvements in imagery fall in 5 big areas. We support new imagery types, like the small sat imagery coming in from organizations like Planet. Also, imagery data management, where we can bring in any kind of imagery that you take from drones and satellites and aerial photography and manage it. In the last year, we introduced a new data type called image cubes, which are multi-dimensional data sets that we can do deep learning and immediate response to analytics on top of. We've added new tools for analysis. You've seen some of them. New tools for visualization and extraction, and new tools for actual map production, including the ability to do pixel editing of imagery, but also automated DTM creation and orthophoto creation and stereo data capture. These, again, are not special tools. They're just part of the standard vocabulary of technology. So I want you to pay attention to imagery because it's the fastest growing big data content on the planet. And we now have tools, as Omar showed, to increasingly exploit and directly use this for mapping, for analytics, and for communicating to others. Like imagery, we're becoming overwhelmed with real-time data, data coming from sensors, vehicle sensors, in situ sensors that are measuring temperature, measuring air pollution, measuring where vehicles are, etc. So the ArcGIS platform reads that sensor data in and allows us to do alerting, allows us to see what others can't, allows us to do analytics. The example that I showed earlier of looking at AIS data offshore here is a perfect example of it. We can see in real time what's going on. So when we often talk about smart cities or smart organizations, real-time GIS is a major part of it. I've talked about the last year's new tools that we've added to the product. I'd like to finish by describing just about the product architecture and the actual components of the product. There really is only one product, it's ArcGIS. It has an enterprise server, it has the Pro desktop, it has open source solutions that work on the product, it has various apps, and more recently, developer tools. Complementing the software is the online cloud system with the content and sharing portal. I'll update you on what we're doing in each of these. The online platform has lots more data. We've added the idea of new user types, which is allowing us to be more scalable, more affordable in organizations. We can now configure the software so that it can read vector base maps and implement your own rendering styles. So you can look at the BIG base map as features, but you can color them and render them dynamically in a browser differently for different applications. New tools for 3D. And what's coming later this year is a new viewer for ArcGIS Online. And later, we will allow you to host your imagery in a completely cloud environment. You can upload the imagery you take share it, analyze it with cloud processing. ArcGIS Pro is our biggest user technology. There are millions of users now using it. Here we've made improvements by adding new capabilities for managing utilities, parcels, new simple tools like dimensioning or spell checking. I need that a lot myself. What's coming is, especially for high-end map making, offset printing, and 3D voxel support for ocean and exploration tools. The third product, the second product is actually Pro extensions, which are extensions for 3D and analytics. Here, I'd like to call your attention to unstructured data. So we're getting, in the world of one data for Indonesia, the president's world, we need to be able to not only integrate in map data or even structured tabular data, but unstructured data, text, be able to read it, spatialize it, and then integrate it in. So Locate XT is a new way to make that interface occur. The third product is Enterprise. This is the server architecture, and it allows us to make a comprehensive enterprise-wide system with apps for sharing, apps for mapping, apps for data management, and apps for making it available through the portal. Here again, lots of new tools. Like ArcGIS Online, we've introduced user types. We've reduced the memory requirements of ArcGIS Server by 95%. So this summer's release means we don't need as big of machines. We can parallelize our processing and make many services available to more organizations. We've seen on the server side some of the work that we've already seen from Omar in the machine learning and AI tools now implemented on the server level. And there's more coming. ArcGIS Enterprise is a scalable, modular architecture. This means I can have multiple machines scale out for very high performance. And there are extensions to this: the image server, the real-time geo-event server, the geoanalytics server for big data, and as I mentioned before, the new Python notebook server. So, ladies and gentlemen, take a look at this diagram. We can have multiple machines at different locations doing various sorts of things, and they are orchestrated by this thing at the top, the ArcGIS portal. So with the enterprise technology comes this embracing tool that brings together, abstracts the information, and allows us to make it available to others. Enterprise portals not only live in one location. As I've been describing earlier, I can have many portals in an organization. I can also have many organizations having portals that interoperate with each other. I can share my data and have it accessible from another organization's portal by just registering the service. This is a very important slide for realizing this notion of geospatial infrastructure for Indonesia. This will happen, ladies and gentlemen. It's already happening, as I described in the vision section of my talk. It's taking GIS to the edge, meaning geospatial infrastructure open and interoperable for everybody. Well, one of the things that we introduced earlier this year is the ability to have more scalable and affordable licensing of our basic tools. We've done this around user types. So free users, viewers, editors, field workers, all the way up to GIS professionals. This kind of scalable architecture means we can have access not just for the GIS professional, but for everybody in an organization and people outside the organization looking and using data. This year we also introduced a new type of user called insights. This is a lightweight geospatial viewer and analyzing tool. Insights for ArcGIS means I can do interactive mapping, analytics, and charting, but not be an expert GIS person like many of you here in the room. It's similar in concept to a business intelligence package called Tableau or Power BI from Microsoft. It allows me to drag and drop data, make charts, do analytics. So while many of you here use ArcGIS Pro as your client, this allows you to spread out geographic analysis to other colleagues across your organization. Esri has a large team building open source software and making it available to the world for free. These are tools and models that focus around industries. So a collection of templates for local government or state or provincial government, a set of templates for utilities, a set of templates that just work for emergency management or defense and security. So if you go to solutions.arcgis.com, as the website shows, you can find hundreds of free software that you can download and build apps for your organization. Now, these apps are available for free, but also part of ArcGIS is a family of tools for building your own apps. The biggest and most popular one is the Web App Builder. This allows, in a web environment, people to create apps in a matter of minutes or hours by taking widgets, organizing them together, and publishing them. There's now over 700,000 of these apps that have been created by our users and shared openly. Also, there's a new generation of Web App Builder coming called Experience Builder. It's just now going into beta. So those of you who are interested in building your own apps, there'll be new generation of tools that are primarily focused around devices. So if you want to get users leveraging your contributions to the geospatial infrastructure, this is a platform. I mentioned early on that a lot of our attention is now focused on developers within your organizations who want to build applications, but also developers in the outside world. And we have 5 different technologies for developers, one of which is the Python notebooks. I described that earlier. Another one is Pro add-ins that make your Pro desktop more powerful. Perhaps the most powerful one is the JavaScript API, which allows people to build browser-based tools. And native device apps can be supported with little runtime components to build apps in iPhones or Android devices. And finally, the full system of ArcGIS is available for Python developers who want to build applications. The most popular one of these, as I mentioned, is the JavaScript API. Now, this allows us to build applications in a browser that access distributed services. This is free, so I can download or use directly the JavaScript API and program client-side web browser-based applications for visualization or analytics. This is amazing tools that are available basically for free that leverage the infrastructure system of records that many of the agencies here are building. So pay attention. It's not enough to just build the infrastructure. It's about sharing the ability to create web apps or device apps for everybody. Esri itself is building a few focused geo-enabled systems. These are on top of the geospatial infrastructure, one for indoor buildings, one for citizen engagement, one for business analysis, and one for urban planning. The one for urban planning is called Urban, and it allows us to set up a 3D model for a city like Jakarta and allows many people to put in their projects and other people to look at them, to evaluate the consequences of different projects against different kinds of indicators. Like if I put this building here, what is the view shed? What is the impact on sewers and water by adding this building? The governor this morning was totally excited by this idea that we could have real estate people, we could have planners, we could have citizens looking at an integrated model with indicators in it to create a better Jakarta or a better city. The second one I'll just mention is Hub. RTS Hub is a system for engaging people in communities. It has open data, so if you want to provide open data to your community, you can use this powerful capability to disseminate your data, tabular data or map data to communities. Second, it organizes initiatives like cleaner streets or more safe or lowering pollution in a city. You can create an initiative, that is a policy person can create an initiative, and then organize a community using social media or digital. It's kind of like having a community meeting, except doing it using social dimensions and social media. Very powerful, now going on in hundreds and hundreds of cities, wanting to engage their citizens in a kind of open democracy about the evolution and planning of a city. Well, ladies and gentlemen, I've talked a lot about content. For some of you, you found some parts interesting, other parts, okay. You didn't understand it. That's okay. That's okay. What I wanted to communicate is that we're continuing to push on the core platform every year. We spend hundreds of millions of dollars creating the future platform for you to be able to use. At this meeting, I want you to give us feedback about what's not working for you in the technology, what's beyond scope, what's not affordable, what's not accessible, and problems that you're having with the tools. This is very important for me. But I also want to share with you our general direction. Esri, after 50 years, is still focused on exactly the same principle. We are not a public company. We've not monetized this company. It's an organization that's designed to serve our users. And they buy and license our tools, but we spend the money on that to advance the fundamental technology and science of what we're doing. This is what gets us excited. We are very strong in engineering, software engineering, and also in analytics and science. And we believe that by supporting you, we can make a difference. And this meeting, this adventure for me today has been very exciting because I can see what you guys are doing. And it's amazing. It excites me. Part of our organization is dedicated to education. Here now in Indonesia, we have been supporting over 30 universities with free software and training to build the next generation of GIS professionals and geospatial professionals. This is important to me. It's important to me that we generate not only knowledge in this room so you can collaborate, but also we invest the time to get more people involved. I'll close by saying a couple words that summarize the big messages of this morning. GIS continues to evolve. You've seen it just in the short couple of minutes that I've shared this. We are moving from GIS to geospatial infrastructure by linking together the components of GIS. And this is creating a very powerful platform. The way I see Indonesia is that if I came back in 5 years, you would be building an infrastructure. That's what I want you to begin to think about, that vision. This infrastructure is going to be responsive, like the nervous system itself. It will reshape how people do their work. It'll automate things. In many ways, the interconnection will transform organizations. They won't do it the same way. They'll do it in real time. They'll start operating at the speed of light they'll connect different sorts of workflows and make not only individuals you smarter, but collectively your organizations more efficient and more effective. Now, you as professionals, I want to speak to you. Your work is part of something that's more than just the making of a map or doing the project work that you're doing. I want you to understand that. It's influencing, it'll influence, your work will influence the future of Indonesia. And you now have the technical means to do it, to create this kind of infrastructure. And, as we heard from the leadership this morning, create the vision of a more sustainable future, not only for your country and your organization, but ultimately the whole world. This vision requires thinking. To realize a sustainable future is not just about the tools. I've talked a lot about these tools, and I'm excited about the tools because in my real experience, I've seen how new technologies influence methods and ways of thinking and doing things. It will require, however, you getting passionate about it. Like if you think back when you first saw the impact and implication of GIS, think about that for a moment. Some of you saw it, you saw what others didn't, and you changed your actual direction as professionals. That kind of passion and hard work and mission, I think, is what's going to be necessary to create this infrastructure. What I might say is going all in. Going all in. Many of you already are all in on working in a collaborative environment and making this happen. But only in the final analysis, only you can do that. I can get you maybe excited about some aspects of it, but going all in means you personally thinking about this and making that kind of decision. So ladies and gentlemen, thank you for this opportunity. Thank you for the opportunity to share with you this morning going all in. Thank you.